So welcome everyone to our scaling instructor training class. We are going to talk a little bit today about scaling VLANs. I know, like I said, that we're behind, but I still want to talk about this a little bit so we can spend just a little bit of time. This particular concept of the VLAN trunking protocol used to be in the Cisco Academy. It was part of the curriculum. We taught it all the time, and then they removed it in the last version. Well, it's back. So we're going to talk just a little bit about it. What it really comes down to is this VLAN management challenge. In other words, if we don't have some way of dynamically sharing VLAN information in a large environment of VLANs, which again, as we've moved to more routed networks, it's still an issue, but it's not as big. But we still need a way to do this, and it's still out there, so Cisco wanted to add it back. But what we would have done traditionally, and what we did before we went back and taught BGP, is you would have had to touch every one of these switches if you wanted to add a VLAN. And then if you added, on the initial configuration, and then also on later additional VLANs being added. That is a huge issue. So basically what we've got is a protocol called BGP, VLAN trunking protocol. Very important that it is VLAN trunking protocol, which means trunking needs to be working before it will work. So we do need to have trunking going on to be able to send multi-VLAN information between the switches so that items can be tagged. But we are going to really talk about a very simple protocol in BGP because it consists of a domain name, which is very similar to a BGP, to a workgroup name in Windows. So if you're part of a domain, you're going to share BGP information depending on what your particular role is in that BGP domain. There are BGP advertisements that get sent out when there are changes. It uses what's called a configuration, basically sequence number. So we'll see it here in a minute, but it's a configuration register number to where every time you make a change, that number is incremented. That's also one of the issues with BGP you have to be careful of that we'll talk about. We'll talk about the modes, and we'll talk about adding a password for security. Now, BGP, we're looking at here, there's version 1, version 2, and version 3. We're not going to talk about version 3. We're primarily going to talk about version 1 and 2 in this course. Now, a couple modes here. I use my old Windows things to describe this, and this is basically, if you're a BGP server mode, you have a read-write version of the database for the domain. So you have the ability, just like your primary domain control in those old Windows NT networks. So you got a read-write version. The BGP client gets the database from the server and also only has a read-only version of that database. So they're like a backup domain controller in the old days. The other difference between the two is the database on a BGP server will survive a reboot because it is stored in the in NVRAM, and you can create, delete, and rename VLANs on a BGP server. On a BGP client, you can't change anything. It can only store the information while the switch is up because it's held in RAM, and as soon as you reset a BGP client, it has to go back out and find a BGP server and get information about the BGP domain. Transparent's a little weird because it is a switch that for whatever reason you don't want to participate in BGP, but you do want it to be able to pass BGP advertisements. So maybe it's sitting between one of your BGP servers, one of your BGP clients. For whatever reason, it is it has its own database. It does not participate in BGP, but it will pass the BGP advertisements. Any questions about these three modes? No, I'm good. Okay. Hey, George. Here is BGP advertisement. So in other words, when a new VLAN is added, a BGP summary advertisement goes out. There also can be BGP advertisement request. So when an advertisement goes out, if it has a higher configuration revision, I was right, then the current value will say, okay, hey, guess what? The summary advertisement is higher. Send me your information about the VLANs. And then you'll get a subset advertisement that says, hey, here's our VLAN information with any changes. By default, too, it will happen every 5 minutes if there's no change, and just lets the BGP switches know what the domain name is and what the configuration revision number. Now, remember, every time you make a change on a server, the revision number goes up. You also need to remember that the only real major security item in BGP by default is the domain name. So we'll talk about that as we move on, because that can cause some issues. But here's our versions. BGP 1 is the default on all switches. Supports only normal range VLANs, which is 1 through 1000. I think that's right. BGP does support normal range plus legacy token rings and the advanced features such as TLV with transparent mode. Again, not that big of a difference, but just, only reason you really use BGP is if you need token ring support. If you're still running token ring, heaven help you. We're not really going to talk about BGP 3, but it is out there as you move forward to look at CCNP training. Now, by default, switches are set to be disabled with BGP with a no BGP domain name set and BGP pruning, which that's something we'll talk a little bit about in a minute. But there's use version 1. The name is null by default. Pruning mode is disabled, and what that means is if you do not have a port in a VLAN that is part of BGP, you will not add that VLAN into your VLAN database, your local VLAN database. And the mode, let me find the mode here. Operating mode by default is in server mode. Now that's why this picture is wrong. It shows transparent. That is something that has been reported to Cisco, but this should say server mode for the default status. So that's something that will you want to tell your students, because it is default of server mode. But there's no domain name, so it really isn't participating in BGP. It's just in server mode. And then you got to check some here, and this we'll look at how you can see actually show BGP password and see the password that's been assigned, which is it's very easy to do. And then you got your configuration revision number, which in this case is 0 again, because there is no domain name, no BGP domain. Now here's where you get in trouble. All right, this is BGP uses that configuration revision number. So let's imagine that you are an employee at a company, and you've been working with a network, okay, and that network has a revision number 17, but you were also working in the lab, and you were using the same BGP domain name, and you kept adding VLANs, deleting VLANs, making changes to that particular switch. And then you plug that switch into your existing network without completely clearing it and rebooting it. So, delete /VLAN.dat, erase startup config, reload. That machine, by default, is a BGP server. It's going to have the domain name, and it has a revision number of 35. And it only knows about VLANs 30 and 40. Well, your corporate network uses VLANs 10 and 20. Well, what's going to happen now is this server is going to send its VLAN database out, and everyone on this network will take this database, will delete 10 and 20, will add 30, 40, and suddenly you've got all these PCs stranded. So they are in non-existent VLANs. Big problem. Okay, especially imagine if you had 30 or 40 VLANs, you connected a switch like this, and you deleted all the VLANs. You've got a bad day, okay, very bad day. So the big thing to teach your students here is, before ever adding a switch into any network running BGP, make absolutely sure that switch has been cleared and reloaded. Otherwise, you could have issues. Okay. Does that make sense? Can you see how this would be very, very bad? You also could reset it by going back to a non-existent BGP domain and back. You know, it says it's not reset if it's saved in BGP. So one of the things you can do is change the transparent mode and back. So if you keep the same domain name and you reset it, you will still have that particular BGP version, that same one. So you have to reset it, change the BGP domain name, and then you can reload it. The big problem that we have seen, again, is putting that switch into the network. The other thing is, hey, in your non-production environment, don't ever use your production names if you can help it. Use something different. You know, instead of Cisco 1, do Cisco test 1. And then that would not have been an issue because it would not put that into this particular thing. And as soon as you changed it, when you put it on the network and changed it to Cisco 1, it would reset the revision number to 0. So it says here it's stored in NVRAM or flash in some platforms, so it depends on what you do. So even if you reset the switch and reload it, it won't cause it. You have to rename the BGP domain. Okay. So be aware of that. Make sure you do it. Now, how do we set it up? This is a very simple protocol. You go to the servers, put the domain name on it, put the password on it if you want it. Well, first off, remember this. It is VLAN trunking protocol. Set your trunks up first. No trunks, no BGP. Then configure the BGP server with the domain name. Configure it with a BGP password if you so choose. Configure your version number if you so choose, and then put your VLANs on that particular server. Okay. Connect the BGP clients, and the BGP clients configure them. Configure your VLANs on the BGP server, and then verify they get the VLAN information. Now, man, I forgot to do that. Let me run over here real quick to NetLabs because I want to let something boot so I can show you something, because there's a major difference between what happens real world and what happens on Packet Tracer on one of the labs. Are there any questions while I'm bumping over here into NetLabs? I apologize. I had a phone call up till right at 3 o'clock. No questions? No, I'll see y'all here on.
No,
Come on, y'all got to have some questions for me.
The only question that I had was maybe what you were talking about on that earlier slide was when you were talking about where you had said that one more, right there when you were talking about what are flash on some platforms. I thought it was always stored in NVRAM, if I wasn't mistaken. And I may be wrong, so.
No, on some platforms, like some of the higher end switches, it actually saved it on flash. So it depends on the platform as to where the BGP configuration revision number was stored. Typically it's NVRAM, and I screwed that up in terms of telling you just to reload it. You do have to change the BGP domain name. I was thinking about configuration register number on password recovery. Sorry.
Well, I just told on. So you're saying it's flash on high-end equipment, and it's NVRAM, I guess, on the.
And really, it just depends on it. Some of the older equipment could use flash too. It just depends on the equipment. It's not necessarily just high-end. It could be other equipment too.
Okay.
But this is the big thing. Make sure you change the BGP domain to a non-existent BGP domain. And then what I would do is change it to a non-existent BGP domain name, change it to transparent mode, and then back to previous mode. And then I would erase it and reload it and then connect it.
Okay.
Because you do want to get rid of those VLANs that are in the VLAN.dat.
Okay.
All right, I'm letting this boot, and I'll come back to it in just a second. So set the server, BGP mode server, very easy. Okay. And now basically you've got 3 different ways you can turn BGP off if you want to. Okay. Set the domain name and password, so BGP domain name password, and then BGP password, and put in a password. All right. Pretty simple so far. Configure the BGP clients. All right. Set the domain name for them, set the password. So you've got all 3 of those. This basically makes it join the CCNA domain and the password here, and then configure the VLANs on the VGP server. Now, quite honestly, you could have done this beforehand. You could have done this when you were doing the initial BGP server and configuration. But once you do that and you see it, now notice, obviously, you're not putting any ports in the VLANs yet. You're just creating the VLANs, and those VLANs will then be shared across to the clients. And you go to your client and do a show VLAN brief or show VLAN, and you'll see that they have been received by your clients and they are available. You also see that it's a client. You see the domain name. You see the MD5 hash of the password. Now, if you create, notice this, if you try to create a VLAN on a client, it will bark at you and say no can do. All right. Now, let me see if this thing's booted up yet. I'm hoping she'll be ready to go here in just a second. In Packet Tracer, one of the major items that takes place is when you add VLANs into a, that's still booting here, let it finish. When you add VLANs into a switch, it will automatically very quickly move over to the other switch. And this is, I'm actually going to show this to you because this is something that confuses students. And it's actually more important than you just sitting there talking about normal range VLANs, because that part you can just read for yourself. All right, so 2960, 2960. Let's connect, well, no crossover, just because I'm supposed to. Gig 01 to gig 01. Okay. So just real quickly, what I'm going to do here is I'm going to go and config T, first off, give it a name, host S1. Then I'm going to go int GI01, switch port mode trunk. That's all I'm going to do. Be lazy. Okay. Then we'll go over here. CLI, let's go to this. In config T, switch port, host S2, int GI01, switch port mode trunk. All right. Do show int trunk, and let's make sure we got, I left everything the same. So we're trunking native VLAN 1, all good. All right. So I'm going to go back to switch 1, and I'm going to back up 1, and I'm going to do BGP mode server. I'm going to do BGP domain. Can y'all see this okay? Example. BGP password Cisco. I'm just going to do that. All right. Now I'm going to go back over to 2 and just do BGP mode client. VTP domain example. VTP, that's because it was in domain, it was in VTP server mode before. VTP password Cisco. Okay. Do show VTP pass, and you'll see it's Cisco. Now, do show VTP status, and you'll see that I'm a client and VTP domain Cisco. Okay. Oh, excuse me, example with password Cisco. So now, if I go over here to S1, and this is what I want to show you that's going to confuse students, especially when they're working on real gear. Type exit to show VLAN. You'll notice that right now I have just standard VLANs, VLAN 1, and then all of my extended VLANs for token ring and stuff. Okay. I'm going to go over here and I'm going to go VLAN 10 name PT. Okay. Now, if I go back over here, look what's happened. This has already been shared between these two. All right. There's a problem with that. All right. When on real gear, that doesn't happen until you exit out of the configuration for the domain, because, or excuse me, for the VLAN, because what really happens by default when, see, it's added it here in PT, but when I go over to the real switch, okay, so here's a real switch. I'm going to go ahead and go int FA03 switch port mode trunk. Then I'm going to do VTP mode server, VTP domain example, VTP pass Cisco. All right. So now I'm going to do a Control Z, show. That's the other thing this will do. It will give you actual messages. 0 logging synchronous. Okay. Show BTP status. Sorry about my phone making noise, folks. So I'm in BTP example. I do show BTP password. You'll see the password is Cisco. All right. Now I'm opening up S3, which is on the other side of the link for this lab. So basically, there's just one connection between S3 and S1. S1. Let me do this because I hate getting that on my screen. Come on, fingers. Logging synchronous. Now, int FA03, switch port mode trunk. Okay, do show int trunk, and I should have a trunk. I don't have a trunk. Why don't I have a trunk? Show me a trunk. What's 03 not be connected? It's not connected. Okay, let me go to the other switch, 01 then. Config. Oops. Sorry it's on the fly, folks, but hey.
No, keep going. I need to know the difference between the reason why you need NetLab over Packet Tracer. Keep doing what you got to do.
Well, here it is, because let me get, man, of course this thing now is massive. Let me close it. Put it over here. All right, so this is switch 2. So, oh God, this is the one that's been. This is the pod. This is, oh Lord, this is pod 3. It's giving me trouble. All right, here, I can actually show you. All right, so you'll notice I did VLAN 10 name PT and then do show VLAN. You'll notice how it's already in the VLAN database, right? Now, that means if it's in the VLAN database, it automatically gets sent over to the other switch that's a client. On a real device, on a real iOS device, if I do VLAN 10, name PT, okay, do show VLAN, you'll notice there's no VLAN in the database. It's not there yet. Because on a real device, until you exit the config VLAN, it does not go into the database. In addition, just like this one joined immediately and said, I've already got the VLAN, I've already got the domain name, real devices don't like to do that. But this is huge, because what happens is people get on real devices. They create a VLAN. Okay, so they go VLAN 20, name, another example, and they stop right there, and then they switch over to their other switch, and they think they're going to see it already there, and then they think that VTP is broken. And it has nothing to do with VTP. It is exactly how Cisco switches work, and it's how they work with this database, because until you exit config VLAN, it does not go into the database. Now that seems like a small, insignificant thing, but you would not believe the number of students who are thrown by that, because it doesn't. I mean, it's totally different than the way it works on the PT. On PT, they'll be in here like this, and they'll go, okay, oh yeah, VLAN 20, name, another example, and they'll go VLAN 30, name, engineering, I can spell, you know, and they've done that, and they leave it there, and they go over to PT, and they go, oh, okay, look, and oh yeah, it's all here, it's working perfect. And then go out in the real world on real gear, and they do that, and they leave it sitting, and the switch in the other building is not grabbing VLANs, and then they spend 4 hours looking at their trunks, looking at their whole thing, and all they had to do is type exit, and it gets written to the actual database, and boom, it works. Okay? So that is a major issue with Packet Tracer and BGP versus the real world. Does that make sense? Because what happens basically, what we used to do, old school, okay, I'm showing my age. It used to be actually that we went to VLAN database from outside of configuration mode. Then they put it into configuration mode, so when you actually create a VLAN, you go into VLAN configuration mode. But you'll see it doesn't get written to VLAN.dat until you leave that configuration mode. Now you can do a Control Z and drop all the way out, and it will also do it because you're out of that mode. So see now, see 40 with no name. But as long as you leave it in that mode, it will not work. So be aware of that. Again, I've seen it so many times with students. All right, any questions on that?
Good to go.
Got it all?
Very good.
Okay. I'm not going to spend a lot of time on these. You can read about them, but extended range VLANs, if you need more than 1,000 VLANs or 1,001 VLANs, you can use these extended ranges. They are available, you know, on 15.x, but you can look, see it says basically between 1,000 and 1,005 are considered normal range, even though 1,000 through 1,002 through 1,005 are for token ring and FDDI. Above that, if you happen to need more than that, you have to turn on extended range. But BGP does not work, well, the V version we use does not work with extended range VLANs. Now, the most number of VLANs you can have is 4096 because of the size of the VLAN ID field in 8021Q. Older switches also supported a method called ISL, interswitch link, but pretty much everything today is 8021.Q for trunking. Creating a VLAN, just showed it to you, VLAN ID, name, and then end will drop you out. And then here's a simple one, and then it will be sent over to the other one if you're running BGP. Assign ports to a VLAN. Remember that is very important because it's not enough just to create the VLAN. You need to assign your ports if you're going to have a port in a VLAN. This is a review of stuff we did in the other one, so I'm not going to spend a lot of time. Show VLAN brief. All of those are different commands you can do. Show VLAN name student if you want just a single VLAN. Show VLAN summary. Again, if you do VLAN 2000, it fails to create it. Depending on what version of iOS you've got. Here's setting it to transparent mode. And with transparent mode, it will do it. If you're running in BGP server mode, it will not do it because BGP does not allow extended mode or extended VLANs. Now, this is a protocol I completely, totally disagree with. This is dynamic trunking protocol. I personally think that DTP should be turned off on every port. That if you're going to do a trunk, you should put switch port mode trunk. The reason they're teaching students about it is because there are many Cisco switches that have DTP turned on by default, and so they want to make sure that you know how to work with it in case of that. The reason DTP is such a problem is because DTP can be used by hackers to create an automatic trunk with your switches. And when that happens, they're then able to see broadcast traffic from all VLANs. So that is a huge issue, and it's one of the reasons why I don't like the BGP at all. It is a Cisco proprietary protocol, so be aware of that. And we'll talk about the different interfaces. Now, the modes. Here's how you can have a port basically set. Switch port mode access, that puts it in the non-trunking mode, so you don't have to worry about it. DTP is turned off when a port is in access mode. If you do switch port mode trunk, DTP is also turned off because it's a permanent trunking mode. All right, it will negotiate with the opposite side, but if you put the other side in switch port mode trunk, then they don't have to negotiate. Both sides are trunked. You also can totally turn off DTP by doing switch port mode trunk, switch port mode negotiate, and then you don't have to worry about it. Won't even send out anything with DTP whatsoever. Okay.
Other than, I'm sorry.
No, go ahead, Mark. That's fine. Yeah, okay. Please stop me anytime anybody has a question. Stop and ask.
Okay. So I had a student pretty much ask me, why even have DTP? And I told him, I said, because Cisco exists. That's the only reason. That's the only practical reason I could give them for using this over a static trunking protocol. I just don't know. Do you have
honestly? Yeah, I'm exactly like you, Mark. Maybe Cisco thought people were too stupid to set up trunks. Maybe Cisco just wanted it to be an easy way to hook two switches together and make them create a trunk. I have no clue. This is something that just flies in the face of all security ideas that you could have. I have no clue. I mean, one of the things that's interesting about trunks now, this is what we typically think of when we think of trunks. We think of this. Well, this day and age, trunks exist not just between switches. We have trunks between switches and servers because our virtualization servers trunk and then do multiple VLANs to our virtualized servers. So to me, it's even more important that only ports that should be in trunk mode are in trunk mode. You want my personal opinion? Every trunk mode should be switch port mode trunk, switch port mode negotiate. Period. Then you don't have to worry about it. Okay? And that may be now the reason why they even put this in the curriculum and brought it back was so people know that. So they know that, hey, we've left this protocol on because for maybe there's some strange case somewhere, okay? And honestly, it could have been the early implementation of IP telephony because, you've got to trunk out to the phone itself to be able to handle both data and the other. CDP typically does that too, though. But that's the only thing I could think that would be useful for it. In this scenario here, where we're creating trunks between switches, I see absolutely zero use for DTP. So we got the voice VLAN command for voice VLAN. So again, your guess is as good as mine on that one.
Yeah, I didn't have a valid reason to tell them.
Tell them somewhere in the wild west of networking, there was a day when people wrote stagecoaches that needed DTP.
Okay, gotcha.
Yeah, just give them something like that.
Right.
I will say this: it is important to know what happens when you put these different modes on. So if it's dynamic auto, this is basically dynamic auto says I'll become a trunk if you want to become a trunk. That's kind of like when you ask your wife where you want to go eat, and she says I don't know where you want to go, and you I don't know where you want to go. And then you sit there for 2 hours and don't figure out where you want to go eat. Hope my wife doesn't listen to this recording. All right. So if one side's dynamic auto and the other side's dynamic auto, it's going to negotiate an access port. If it's dynamic auto on one side and trunk on the other, dynamic desirable on the other, you will get a trunk. In other words, what happens is this one says, well, I'll be a trunk if you want to be a trunk. The other side says, yep, I want to be a trunk. You're a trunk. Remember, if it's dynamic auto and you've trunked it but not put in no negotiate, the trunk will still say, hey, yeah, I want to be a trunk and become a trunk. This is a problem if you don't put in no negotiate because a hacker, can set their Linux laptop to a DTP variant, say I'm dynamic auto or dynamic desirable, and if you set switch port mode trunk only, then they will actually become a trunk. So that's a problem. If you do switch port mode access on one side and dynamic auto on the other, you will get an access. Same thing here across, you see how that works. And then here, if you get a trunk on one side and limited connectivity or an access on the other, then you do have limited connectivity, because that basically says that one side is tagging VLAN, the other side is not tagging VLAN, so you can end up with a mess. Okay.
How much exposure is the DTP on the ICMD2?
Not much. I mean, there's not going to be. I would know these modes, you know, but I wouldn't be all that. I wouldn't worry too much about it.
Yeah, I know. Yeah, GRP is going to be there. I just
oh yeah. And they do want you to kind of know like this: if it's dynamic auto and trunk, what's it going to be? It's going to be a trunk, right? That's not working. That's a trunk. Dynamic, desirable, and trunk. Trunk. DA, dynamic auto, it's going to be an access port. So, you know, that's the kind of thing you need to know. Deleting the VLAN is easy. Just delete the VLAN. Be very careful though. Remember, remove your ports from the VLAN first, then delete the VLAN. If you don't, you end up with orphan ports. Those ports will go in an amber, they will actually go amber, and they will no longer appear anywhere in your list, and you'll have to move them back to VLAN 1 by default. Now, best practice, take all ports out of VLAN 1, put them into a black hole VLAN, and that is a VLAN that has no data traffic on it. So create VLAN 555, move all the ports out to it, and then distribute your ports where you want them to be in the correct VLANs. You really should not have any ports left in VLAN 1 at all, because that, again, is a security feature to make sure if somebody plugs in, they're not in VLAN 1 and you have no traffic on VLAN 1. Some issues, big things here, and you can read. I'm not going to spend a lot of time, but wrong ports, wrong VLANs. Really, there's not a whole lot of issues that you can come into with VLANs other than forgetting to do a VLAN and forgetting to put it into put a port into it. The other thing that some issues with BTP I see is fat finger and the password's a big one. Forgetting that the domain name is case sensitive. So if I'd used capital example instead of lowercase example on one side, that is two different domains. Being in the incorrect mode. And on DTP, the big problems I've seen is leaving both sides dynamic auto and dynamic auto. Again, don't like DTP. Interface issues, again, that's just being in wrong VLANs, using multiple. Forgetting to do your encapsulation correctly and putting it in the correct VLAN. This is something very, very common. I mean, encapsulation.1Q100, this tags everything on this particular network for the 100 VLAN when it's supposed to be VLAN 10. Do you remember what this is called here? What do we call this? When we've got a router configuration like this.
Like a router on a, oh my gosh, router on a stick? Is that
yep,
what that
that's
is?
it. It's just a router on a stick. Yeah. This is router on a stick. Same thing we did in semester 2 that we did and learned how to do. IP address, subnet mask errors here. We put the wrong IP address. This is traditional where you've actually got an interface for each VLAN, something you won't see very much. Okay. All that's pretty much the same, so I'm just going to blow through that. BGP issues, again, incompatible versions, passwords, domain names, all switches set to client mode, and then that major problem you can have when you mess up the configuration revision number by adding a switch into the network with the same BGP domain name. Remember the way to reset it, I told you wrong earlier. The way to reset the configuration revision number is to place the switch in a different BGP domain than the one that you're going to be adding it to, and then putting it back in that BGP domain before you add it to the network, or set the switch to transparent mode and then move it back to whatever mode you want it to be. So I fixed my mistake. BGP issues, trunk mode mismatched allowed VLANs on a trunk. Remember that, that's something, switch port mode trunk. switch port trunk loud VLANs, and then native VLAN mismatches when you set the wrong native VLAN. By default, what's the native VLAN on all trunks? George, you remember? Mark, anybody?
Should be, is it 99? No.
Nope. 1. George put it to 1. Yep.
Oh, I didn't even, I'm not even looking at, okay.
Yep, the chat, yeah, but George dropped, that's right, 1. It is 1, which can be an issue because that means that's the untagged VLAN. So some people say to put your native VLAN onto a non-data VLAN that you don't move anything on. Now, real quick, layer 3 switching. This is kind of a an interesting thing because one of the first things I was asked when I interviewed an ISP is, how do you make a port on a switch into a routed port? And the correct answer is type no switch port on it if it supports it. Not all of them do support it. Believe it or not, though, the 2960s do support it. You can actually load an SVM prefer image and do very simple layer 3 switching on a 2960. The other way to do it is with switch virtual interfaces, and so on some of the higher end switches, and even not super high end, but just the layer 3 switches, what you do is you go in and create a VLAN interface, and then that interface can actually route on the layer 3 switch. So if I had, for instance, sorry y'all, phone's going to be ringing, folks. I can't stop that, but I'm not going to answer it. But if I had a, let's say, VLAN 10, 20, and 30, and I wanted to route between them all with D1, I would create 3 switch virtual interfaces, one for interface VLAN 10, 20, and 30, put an IP address on them, and then make sure that routing is turned on D1. Here again, inter-VLAN routing, we don't do a whole lot with it here. We do have one lab where we're going to set it up, but it's not anything major. You see here they're creating their VLAN interfaces. So again, they do an SPI for VLAN 10 and one for VLAN 20. And if it's a layer 3 switch, it can just route between those if you've turned it on. Some layer 3 switches you actually have to put in IP routing and turn it on. And actually on a router you can do no IP routing. That's fun to do sometimes. Hold on a second, folks. Somebody's really trying to get done. My boss trying to send me a phone call. I'm like, I'm in class. But see, it's faster than a router on a stick. One reason it's faster than a router on a stick because it's all done in the switch backplane. It's not, it doesn't go out to an external router and come back. This is how we do it in the real world, folks. We're doing most of our routing on layer 3 switches, except for big ISPs with their massive routers. So again, the no switch port command, I think this is the 3rd time we've seen this. Okay, the routed ports are not supported on the Catalyst 2960, but you can actually do some basic with the STM. So they actually have a nice packet tracer where you pull over. I will say that there's a layer 3 switch and packet tracer you can play with. Issues: VLANs not being defined, SPIs having incorrect IP addresses, turning on routing, okay, and then correct IP addresses for the host. So really the same issues you have with the router on a stick. It's just that it's all internal to the layer 3 switch. For some reason my fingers keep always hitting on that. All right, I want to stop here. Are there any questions before we move forward? I know a lot of you are still trying to catch up. I'm going to stop sharing my desktop. Many of you are still trying to catch up with the class. The good news is we're not that, we're still doing okay. We're not in bad shape. Some of you are way ahead. George, I think you have some of the best documentation